Okay, good morning, good afternoon, good evening, whenever it is that you're watching this. Today we're going to be looking at something called the factor theorem. So what's going to be really useful is if you've watched my video on dividing polynomials, then if you haven't, watch that now, but if you have, we're going to be looking at, well, questions which dividing polynomials will come into some use later on. So looking at this then, we've got some sort of question, and it's x cubed plus x squared minus 4x minus 4 equals x minus 2 and x squared plus 3x plus 2. So looking at this, I can see that this cubic has a factor of x minus 2 and a factor of x squared plus 3x plus 2, or x plus 2 and x plus 1 if you expanded that. What's really useful to note, though, is if it's got a factor of x minus 2, what would happen? What happens if x equals 2? Well, let's think about this. What would happen to this right-hand side if x equals 2? Well, looking at it, this x minus 2 term is going to be 2 minus 2, which is 0. And we know that 0 times by anything is going to be 0. So that right-hand side reduces to 0. And as they're equal, that would mean the left-hand side has to equal 0. So what we get is this really nice property that if we know a factor, we can think about what happens to the whole function. So the factor theorem just states that if we've got a function, which is f of x, so x cubed plus x squared minus 4x minus 4 in this case, if we know it as a factor of x minus p, so in our case it was x minus 2, then the f of p equals 0, and that must be a factor of f of x. And we can use that backwards, which is what we did by looking at the x minus p. The best way to demonstrate this is actually going through a question. So the questions will typically be shown like this. It will say, show that x minus 2 is a factor of x cubed plus x squared minus 4x minus 4. And what we have to do is, well, I'm just going to let my f of x, so my function, be equal to this x cubed plus x squared minus 4x minus 4. The value of x that I'm going to change it to, well, if it's x minus 2, to make that equal to 0, my x value would have to be equal to 2. So working this out, 2 cubed plus 2 squared minus 4 lots of 2 minus 4, well, 8 plus 4 minus 8 minus 4 equals 0. So therefore, f of 2 and x minus 2. So therefore, f of 2 equals 0. So x minus 2 is a factor. Lovely. So that would be one type of question, and that would be the generic question that you could get asked, and hopefully you could work that out quite quickly. The other way we can use this to actually help us out with some factorization. So here we need to fully factorize 2x cubed plus x squared minus 18x minus 9. To do this, I'm going to think about how can I factorize this? Well, I'm looking for some factors to start off with. So again, I'm always going to start off by saying let f of x equal, and it's going to be 2x cubed plus x squared minus 18x minus 9. And I know that my 3 constant terms, so my factors, must multiply together to make 9. And the only values that do that are 1, 3, and 9, because we can have 1 times 9, sorry, or 3 times 3 times 3. So I'm going to try that. I'm going to try the values of 1, and I'm going to try the value of negative 1 to start off with. So f of 1 is going to give me 2, 3, minus 18, minus 9. So it's going to be minus 27. So that's going to be minus 24. So that doesn't work. If I try f of negative 1, that's going to give me minus 2, positive 1, positive 18, minus 9. It's going to give me some value which isn't 0. I think it might be 24. So I'm going to now move on to 3. I'm going to try f of 3. And what does that give me? Well, 3 cubed is 27 times 2 is 54, plus 9, minus, well, 18 times 3 is going to be 54, minus 9, and that's going to give me 0. So therefore, I know f of 3 equals 0, so x minus 3 is a factor. So given x minus 3 is a factor, I can then reduce this down because I know by my polynomials, I can factorize this by just dividing. So I've got x minus 3, and my first thing it makes me is 2x cubed. So this must be 2x squared. So it's minus 6x squared. To get from minus 6x squared to plus x squared, I need to add 7x squared. So therefore, x add 7x squared is going to be add 7x. So it's going to be minus 21x. To get from minus 21x to minus 18x, I'm going to add 3x. So this is going to be plus 3. And 3 times minus 3 is minus 9. And again, therefore, I know I'm correct. So I've got x minus 3. And then my quadratic term is 2x squared plus 7x plus 3. 2x squared plus 7x plus 3. And if I want to fully factorize this, I need to factorize this quadratic. Well, it's going to be x equals 3 and 1. So I've got x minus 3. And then I'm going to have 2x squared, 2x, and it's going to be plus 1. And x plus 3. And again, that would be me fully factorizing this cubic by using the factor theorem here and then dividing polynomials. So they also like to mix it up a little bit and ask us a bit more of a problem-solving question. And the way they do this is they use some sort of variable within our cubic. So we have to use a factor theorem to start off with, and we're given that 2x plus 1 is a factor of 6x cubed plus ax squared plus 1. Therefore, if I let 6x cubed plus ax squared plus 1 be my f of x, then what I can do is I know that 2x plus 1 is a factor. So 2x plus 1, as it's a factor, I'm going to set it equal to 0 to get x equals negative a half. And if I do now f of negative a half, because that's what I worked out x to be, I know that this must be equal to 0. So this equals 6 lots of negative a half cubed plus a lots of negative a half squared plus 1. And again, I know that must be equal to 0 using the fact that it is a factor. Working this out, minus a half cubed, well, it's going to be negative, and it's going to be over 8 because 2 cubed is 8. So this is negative 6 over 8 plus a lots of, well, this is going to be a quarter plus 1 equals 0. So it's minus 3/4 plus a quarter a plus 1. So I'm just going to write that down. So minus 3/4 plus a lots of, well, a over 4. And I'm going to change this 1 to be 4 over 4 equals 0. So I'm at minus 3. A must be minus 1 to get minus 3 minus 1 plus 4 equals 0. So therefore, a must be equal to minus 1. So I'm just going to change my f of x, because my f of x would be 6x cubed minus x squared plus 1. So that would be it for this type of question where we have some sort of unknown that we need to find out. So what I'd like us to do is, this is for you to have a go at, so I'd like you to pause the video now, please, and have a go at these two questions. I have got rid of part A because I don't want to test you on that. However, have a look at these two questions, please. So pause now. Okay, and once you've done that, well, here I'm just going to say that f of x, it's already been equal to this. Use the factor theorem, show that x plus 2 is a factor. So therefore, what I'm looking at is f of negative 2, and I'm just going to substitute that in. So I've got 6 lots of negative 2 cubed plus 13 lots of negative 2 squared minus 4, and I can work that out. Minus 2 cubed is going to be minus 8 times by 6 is going to be minus 48. 13, this is going to be positive 4, so 13 times 4 is plus 52, minus 4, which does indeed equal 0, as required. Factorize f of x completely. Well, I know that x plus 2 is a factor, and I know that my other term, I'm going to have a 6x squared. To get from positive 2 to negative 4, I'm going to need a negative 2. And then I can do a bit of maths to work out the middle term. Well, it's going to be plus 12x squared. I need another x squared, so it's going to have to be plus x. We can check that. 6 times 2 is 12. X times x is x squared, so that would be 13x squared. Again, I'd check to see if I can factorize this. It doesn't look like I can do, but you could always just check on your calculator if you needed to. So I'm going to leave that as my answer. Given that 3x minus 1 is a factor of this term, determine the value of a. Well, I'm going to let f of x equal 3x cubed plus 11x squared plus ax plus 1. And if it's 3x minus 1, I'm just going to solve this equal to 0. And that's going to give me x equals a third. So therefore, I'm looking at trying to solve the function of a third. And again, I'm going to set that equal to 0. So that's going to equal 3 lots of a third cubed plus 11 lots of a third squared plus, well, it's going to be a over 3 plus 1 equals 0. A third cubed is 1 over 27, and 3 over 27 is 9th. So it's going to be 1 over 9, add, well, 11 over 9. A over 3, I'm going to change to be 3a over 9, just so everything is over the same denominator, and plus 1 is going to be 9 over 9, and that's equal to 0. What you can do now is you can multiply everything by 9 to cancel this out, so you get 12 plus 3a plus 9 equals 0, so 21 plus 3a equals 0. Oops, didn't need to put that a there, so it's 21 plus 3a equals 0, therefore a must equal negative 7. Sorry, it's a little bit messy, however, that would be it for that question. So what I'd like us to do, once you've done that, is if you could have a look at exercise 7c, there should be some questions testing you on the factor theorem. So thank you very much for watching. If you have any questions, you can email me, but besides that, well done for watching, and I hope you enjoyed.